المحور السادس لمادة نظرية الآلات Theory of Machines والذي بعنوان Gears. We'll continue by presenting calculation of velocity ratio in epicyclic gear train, and I will present first method which is tabular method. Consider an epicyclic gear train as shown here in this figure. So ZA, this is the number of teeth in gear A, ZB is the number of teeth on gear B. We know that NB divided by NA is equal to ZA divided by ZB. Since NA is equal 1 revolution, therefore NB should be equal ZA divided by ZB. On this table, we'll put here in the first column the number of steps or configuration of this epicyclic gear train. In the second column, it is presented here the conditions of motion or of different configuration. Last big row, this one, this is for speed calculation for arm, for gear A, and for gear B. Let's see how to calculate them. For the first configuration, the conditions of motion are the arm, or the first one, arm is fixed, gear A rotates through +1 revolution anti-clockwise. A makes 1 revolution anti-clockwise, it is +1. Then the velocity of the gear B, it is minus ZA divided by ZB because it will be on the clockwise direction. Arm is fixed, that means velocity is equal to 0. Okay. Second configuration, arm is fixed, so velocity or speed is still 0. Gear A rotates through +x revolution, okay, anti-clockwise. Then here we have +x revolution, and then velocity or speed of gear B will be x multiplied minus ZA divided by ZB. In the third configuration here, we will add +y revolutions to all elements. So we'll start by the arm, here +y, for the gear B also +y, and for the gear A, and B +y. Last step will make the total motion. So here we have the sum plus y for the r, this is NC, x plus y, this is NA, and this is NB, y minus x multiply ZA divide ZB. So this is this method is very direct and very simple. Let's move now to algebraic method. In this method, the motion of each element of the epicyclic train relative to the arm is set down in the form of equations. The number of equations depend upon the number of elements in the gear train. But the two conditions are usually supplied in any epicyclic train. Some element is fixed and the other has specified motion. These two conditions are sufficient to solve all these equations and hence to determine the motion of any element in the epicyclic gear train. Let the arm C be fixed in an epicyclic gear train as shown in the figure here. C is fixed. Okay. Therefore, speed of the gear A relative to the arm C, it is equal to NA minus NC, and the speed of the gear B relative to the arm is equal to NB minus NC. Since the gears are A and B are meshing directly, therefore they will revolve in opposite directions. So NB minus NC divided by NA minus NC should be equal to minus ZA divided by ZB. Since the arm is fixed, NC is equal to 0, and then NB divided NA is equal to minus ZA divided by ZB. Now if the gear A is fixed, then NA is equal 0, and then NB minus NC should be equal to 0 minus NC. It is equal to ZA divided by ZB, and we can find NB divided NC is equal to 1 plus ZA divided ZB. So it seems a lot of calculations in the second method. Note, the tabular method is easier and hence mostly used in solving problems on epicyclic gear trains.